like this, and here C is their continuous support, and the far end here is also like this. Now what's happening here? The loadings, we'll write down the loadings. This is 50 kilonewton, 2 meters, 2 meters, this is 4 meter, this is B, this is C, this is D, and as well as here 30 kilonewtons point load is acting, this is 2 meters, this is 3 meters. Now in this what happens is, along with this at B, overhanging portion is there. This overhanging portion, we can convert it as a moment. So how can we convert it as a moment? The value is, just see this one. So due to the loading, it is trying to bend like this. The loading, it is trying to bend like this. So I can apply a moment like this, which is 40 into 2. So a loading that is acting at B, I can convert in terms of moment. So this overhanging portion, it can be converted as a moment, and which is 40 into 2 is the external loading. Whereas here 20 into 1.5 square by 2. So this is also minus 22.5. So I can write down this as 22.5 kilonewton meter. Consider BC. So considering B and C as fixed ends, MFBC is equal to minus WL by 8. So with this you will get it as minus 25 kilonewton meter, which is fixed moment at BC. As well as at CB, you will get it as positive 25 kilonewton meter. So now coming to MFCD. MFCD is minus WAB square by L square when a point load is acting at some eccentricity, not at the midspan. So here a fixed beam with a point load W, and this is A, this is B, this is span L. Now the moment at this one is WAB square by L square, which is anti-clockwise, that's why it is considered as negative. And this is WA square B by L square, which is clockwise, that's why this is positive here. Now you will get the values as minus 21.6 kilonewton meter plus 14.4 kilonewton meter. Along with this one, if you observe your beam, at B, overhanging portion is there. So here what happens is this beam tries to deflect like this. But the moment at this portion, it tries to resist in this direction. And the value of the moment is nothing but 40 into 2. So this is 40 into 2 is acting a moment, and this is acting as a clockwise moment. That's why we will consider it as positive. So MBA will be considered as plus 40 into 2 kilonewton meter. Whereas coming to D, this beam tries to deflect like this, but here the resistance will be given by the moment here. And in this portion, the moment value will be, here UDL is there, and you know that WL square by 2. So W is 20 into 1.5 square by 2. So that will give you the moment which is in the anti-clockwise direction. So that's why keep it as negative. That's why we have written them as MBA is equal to plus 40 into 2 plus 80 kilonewton meter. MDE is minus 22.5 kilonewton meter. Try to do along with me. Now calculating the distribution factors. So at the joint C only we need to calculate. So when you calculate distribution factors at joint C, you will get the values as the ratio of relative stiffness of the member to the summation of the relative stiffness of the joint. So at the joint there are two members are meeting, CB as well as CD. So relative stiffness is nothing but here, that is a continuous support only. B is a continuous support. So I by 4 by I by 4 plus I by 5. So you will get it as 5 by 9 as well as 4 by 9. I think you might have done all these things. Now after getting these distribution factors, now go to the beam once again. Draw the beam. Write down the distribution factors. write down the fixed end moments. Now, just till now you can do it, but here what is the thing is, here you should not balance something like the difference. Here the thing is, the final moment MBA value is plus 80. So MBC should become minus 80. To satisfy the joint condition, MBA is already plus 80 and MBC should be equal to minus 80. And here also, MDE is minus 22.5. And this is a moment, overhanging moment at D. And this should be equal to the joint condition. To make it satisfied with the joint condition, this should be plus 22.5 and make it to 0 addition. So to make it to 0 or to satisfy the joint condition, already the fixed end moment existing is minus 25. So here to make it as minus 80, you need to add minus 55 here. So you are balancing at B with minus 55 moment. Similarly, to make it as plus 22.5 here, you add plus 8.5 here. So when you are adding this, so obviously carryover moment will be there. This carryover moment will be to the far end, which is fixed or continuous. So for BC, the far end will be CB. So here the carryover moment is obtained. So this carryover moment will be half of the balance moment. So this is plus 8.1 and this is plus 8.1 by 2. Now you can write down the net moments. So when you write down this net moments, so you will get it as plus 80 minus 80 minus 2.5, that is addition of this one, plus 25 minus 55.7, 55.2, sorry, plus 25 minus 55 by 2, which is minus 2.5, and this value is minus 17.55. And here you can check it, the joint condition at B as well as the joint condition at D, both are satisfied. Now when you are balancing this, so what you have to balance, this joint C is to be balanced. So just take the summation of these two, so which is minus 2.5 minus 17.55, which is minus 20.05. And this value is to be taken as opposite sign with opposite sign, which is plus 20.05 into distribution factor, that is 5 by 9. This is plus 20.05 into 4 by 9. So he should not carry over this one. You should not apply carryover moment, as already B as well as D support, they are balanced and there will be no carryover moment. So that's why carryover moments will be 0 here. You can write down the final moments. So the final moments are written. So when you get these final moments, so then continuation of this, we can calculate bending moment diagrams as well as shear force diagrams. So in this to draw bending moment diagram, so we already know that we need to extend the lines. So in this, first of all, draw the baseline. So this is the baseline. Now in this, draw first of all simple supported bending moment. Then we will go with our negative bending moment. So in this, first of all, at A, the moment is 0. But whereas, as this is creating a cantilever and this will bend like this, which is hogging. So hogging is negative and the value is here, downward direction. So you can consider as just forget about AB. We'll draw from B to D, then we'll come back once again for DE as well as AB. So let me complete first of all for BC. So this is your point load which is acting at the center, 50 kilonewtons. So you can consider it as like this. For a simple supported beam with pointer at the center, the maximum minimum is W L by 4. So 50 into 4 by 4, which is 50 kilonewton meter, which is positive. So this positive minimum. Whereas coming to this, so this is a span of 5 meters and this is acting with a distance of 2 meters. You know that the bending moment value is WAB by L. I am writing for simple supported beam. Just see this one. This is positive bending moment diagram. So 30 into 2 into 3 by 5. 12, 36. So the value is 36. So this is also linear as point load is acting. So when it is linear, so this is 36 kilonewton meter. Okay, so now we'll see the negative bending moments, how they are formed. And now to consider that one in this. Now, what is the fixed end moment at B? What is the fixed end moment at B? So fixed end moment at B is so moments are negative only. Support moments are all are negative. So this is 80 negative, and this is 8.63 negative 22.5. So I will write down this as 80. So this is 80. Here it will be there, and just overlapping one over the other. So that is positive bending moment will be overlapped with negative bending moment. So this is minus 80, support moment minus 80. And the next one is 8.63. So this is 8.63 here, somewhere here it will be there. Next one will be support moment 22.5. So the 22.5 will be there. So just join them as a straight line as it is negative bending moment. So, and this is like this. So now this is negative. This portion is negative. All are straight lines only. It is not any curved portion. Everything is straight line. So this is positive here. This is positive, and this portion is negative. So if you do hatching, so hatching means the portion where the bending will take this and the remaining portion it nullifies. So this is your bending diagram. Analyze the given continuous beam. Analyze the given continuous beam. So this is the beam given, and the loading is given as 20 kilonewton meter. Loading is acting here, and a point load is acting at center, which is 4 meters, which is 4 meters here. Everybody has to do this problem. Try to solve this, which is a simple one, and you people have to show me. So just let me know how many of you are able to solve this problem. Analysis of continuous beam. With support settlement. Analysis of continuous beam with support settlement. So that means you can consider this as sinking of the support. So till now we have seen the problems where there is no effect of the support. Whereas now here the analysis of a continuous beam with support settlement is considered. Just you know that a fixed beam is there. In this fixed beam, when the support B is down, which is sinking by delta with respect to A. So here this is a deflection like this, and in this one delta is the sinking of the support. So when the support sinks by delta and the support here it is B dash, in this one the moments are here, the moment is nothing but 6 EI delta by L square, and here also the moment is 6 EI delta by L square. You can check it here. This is anti-clockwise direction and this is clockwise direction. Sorry, both are anti-clockwise direction. So that's why the moments are MAB. So you can consider this as fixed end moments due to sinking of the support, which is minus 6 EI delta by L square. We have already done with this in the slope deflection method. So in this one, this moment, additional moment that is obtained due to support settlement is minus 6A delta by L square. So this is MFBA will also be minus 6EA delta by L square. Note on these things. So why we are getting it as negative? You can see that here it is in the anti-clockwise direction. So when it is in the anti-clockwise direction, so here as per moment distribution method, anti-clockwise will be considered as negative. So this is A and this is B, and now you can observe this when support B is got lifted up. So this is by delta. So when it got lifted up by delta, that is the support change has occurred. So the moment here will be, just understand what happens is at this support, as it is fixity is there, so it will resist the rotation. It will so that's why the beam tries to deflect like this, and at the fixed ends the rotation is 0. So here you can observe that here the moment will be in the clockwise direction and the value is 6 EI delta by L square. And this is also in the same moment direction like this, which is 6 EI delta by L square. So you can observe here now, as the moments are in the clockwise direction, the moments will be considered as positive, which is plus 6 EI delta by L square. And MFBA will be plus 6EA delta by L square. So both having the same direction, and this will be positive 6EA delta by L square. So these are the moments that are to be considered while observing the continuous beam with support settlement. So here remember, anti-clockwise is negative, clockwise is positive.